Welcome back to the network security training. In this video, we will be discussing OSI and TCPIP networking models. Basically, these models are the two most widely used networking models for communication. There are some similarities and dissimilarities between them that we are going to discuss, right? So as you can see here, one of the major differences between OSI and TCPIP is that OSI is a conceptual model which is not practically used for communication, whereas TCPIP is used for establishing a connection and communicating through the network. OSI stands for Open System Interconnection, that is created by ISO, an international standard organization. It was designed to be a reference model for describing the functions of a communication system. It basically provides a framework for creating and implementing networking standards and devices, and also it describes how network applications on different computers can communicate through the network media. Alright, OSI model has 7 layers, as you can see, each of the layer and its function. So in this we have 7 layers: physical layer, then data link layer, network layer, transport layer, session layer, presentation, and at last we have application layer. Alright, so let's get know the functionalities of each and every layer and the protocols that are used on that particular layer. So let's talk about first physical layer. Basically, it transmits the individual bits over the transmission channel. This is named as physical layer because it is responsible for the transmission and reception of wire level data. You can understand by an example that the physical layer is where it is dictated how bits are represented across a specific networking medium. Alright, the physical layer basically deals with the description of the characteristic of the interface between the devices and the transmission media. Representation of bits, synchronization of the bits, data rate, physical topology, line configuration, and transmission mode. The protocols that are used at physical layer are Ethernet, Bluetooth, wireless, and more. We'll talk about the protocols in our next video. Next we have data link layer. So data link layer is responsible for transforming the raw transmission service from physical layer into a reliable link. It basically makes the physical layer free from error by masking them so that the network layer does not notice them. Right? In this layer, the input data is split into frames. The tasks carried out into the data link layer are framing, access control, physical addressing, error, and flow control. Alright, then next we have networking layer. So you can see basically logical addressing and routing are the major operations performed by the network layer. The third layer, it's network layer, right? And it functions for path determination and logical addressing. It basically translates the network logical address into physical MAC address. And that's why here we use protocols like ARP and RARP, Address Resolution Protocol and Reverse Address Resolution Protocol, to translate the networking logical addresses into physical address or physical address into networking address, logical address, so that the two systems residing in the different networks could also communicate efficiently. Alright, a packet also requires a path to be followed to reach at the destination, avoiding congestion and failed components. So it also facilitates the automatic updation of the routes. As I said, at this layer we use ARP, RARP, these IP addressing protocols. All right, then next we have transport layer protocol. So basically it supports end-to-end connection and reliability. Here we use protocols like TCP, UDP. All right, it basically accepts the data from its preceding layer into the form of independent packets and transmits it to the succeeding layer in proper order. The other function that is carried out by this layer are service point addressing, connection control, segmentation, and resembly follow control and error control. Because it supports basically reliability. Right? Then next we have session layer. So this layer establishes the session between different machines in order to synchronize and maintain the interaction between them. The services provided by the session layer are dialog control, token management, session management, synchronization, and so on. Then we have presentation layer, and here you can see it functions for data representation and encryption, and the protocols that are used at this layer are XML, JSON, and all. Presentation layer basically focuses on the syntax and semantics of the transmitting information. It performs tasks such as translation, encryption, compression, where the actual information existing in the form of character strings, numbers, symbols is encoded into bit streams, converted into another form and compressed. And at last we have application layer. So here you can see the protocols that are used at application layer are HTTP, SFTP, SSH, HTTPS, FTP. Right, all these protocols are used at application layer, and this layer uses basically can access the network by using interfaces and services like electronic mail, shared database management, file access transfer, and other services. By using these protocols like HTTP, FTP, SMTP, by using these protocols, the user can use the applications of email communicating or shared databases. They can use file transfer protocols. They can use for forwarding, for sharing the files, right, accessing World Wide Web and all. All right, so this is all about OSI model. Next, we are talking about TCP/IP model. So as you can see here in TCP/IP model, we have 4 layers, right? This model was created in the 1970s by the Defense Advanced Research Project Agency, that is also known as DARPA, as an open, vendor neutral, public networking model. The IP protocol, Internet Protocol Suite, is the conceptual model and set of communications protocols used in the Internet and similar computer networks. This is commonly used as TCP/IP because the foundational protocols are used TCP and IP. TCP, Transmission Control Protocol, and IP, Internet Protocol. All right, you can see here in this model we have 4 layers: application layer, transport layer, internet layer, and network access layer. So you can see at network access layer, it's also known as link layer, is the lowest layer of the TCP/IP model. It is also referred to in some text as the network interface layer. Right? The link layer combines the physical and data link layer functions into a single layer. This basically includes physical network functions like modulation, line coding and bit synchronization, frame synchronization, error detection, and so on. Then we have internet layer. This internet layer is the next layer, right, and is associated with the network layer of the OSI model. Its functions include traffic routing, traffic control, fragmentation, and logical addressing. Common protocols that are used at this layer includes IP, ICMP, IGMP. All right. Then we have transport layer. So the transport layer is typically related directly with the same named layer in the OSI model. As we have transport layer also in the OSI model, all right. Functions include message segmentation, acknowledgement, traffic control, session multiplexing, error detection, error correction, message recording. All right. The protocols that are used are same like TCP and UDP. We use at transport layer. And at last, we have application layer. So the working of application layer is same as in OSI model. All right, here we use protocols such as HTTP, HTTPS, FTP, SSL, DNS, SMTP, and so on. So this is basically the combination or the next version of OSI model, right? Next, you can see the difference between OSI model and TCP/IP model. So through this figure, you can just see that we have combined two bottom layers, physical layer and data link layer. We have combined these two layers and in TCP/IP model and named as a network access layer. All right. Then OSI model network layer is known as internet layer in TCP/IP model. Then we have transport layer in both models. Then the upper three layers, session layer, presentation layer, and application layer, are combined in TCP/IP model and named as application layer in TCP/IP model. All right. And as I said, you can see the protocols that are used at these layers. Like at network access layer, you can see we are using Ethernet, token ring, ATM, frame relay. These are the protocols. Then at internet layer, you can see ARP, RARP, IP, IGMP, ICMP. These are the protocols at internet layer, or you can say network layer in OSI model. Then at transport layer, we use TCP UDP, and at the upper layer, you can see HTTP, SMTP, Telnet, FTP, DNS, RIP. It's for voice communication, SNMP, right? So this is the complete protocol suite of TCP/IP model, right? In practically, we use TCP/IP model, all right, and we don't use OSI model practically. So this is all about OSI and TCP/IP model. In the next video, we will be discussing networking types. So stay tuned.